Welcome to the project demonstration of solar wireless electrical vehicle charging system along with voltage monitoring on EV vehicle based. So here the main application of this project is we are going to charge electrical vehicles based on wireless power transmission concepts. So generally while we are want to charging the electrical vehicle batteries, then we need to stop the vehicle, and then next we need to get down from the vehicle, and next we need to insert the charging cable properly into that. So set properly. So whenever we are inserting, there is any spark got occurred, so then there is a like short circuit will be occurred inside the battery pack, and it's not safety for always to get down from the car. So in order to eliminate these two problems, we have come with a solution of wireless charging of EV vehicle based on the wireless power transmission concept, and also the status of the receiving section will be displayed on the LCD screen along with LED indication on this electrical vehicle system. So for the purpose, we are making use of this transmitter module as well as a receiver module, and the transmitter module will need a DC power supply. So whenever we set the DC power supply, we can store a DC power in a battery. So for that we are making use of this 12 volt 1 amp rechargeable battery pack, so which can be recharged through the renewable source like solar panel as well as from the grid. So when we want to charge the battery pack from the solar panel, just we need to place the kit connection over there. As you can see, the due to low intensity, we can see the low intensity from the LED, and we can charge solar battery pack parallelly other from the grid also. Okay, so there we can see the light indication on the charging circuits. So if you want to charge a battery from the solar panel or transformer individually, it will take around 3 to 4 hours to be get fully charged. Till the duration, we should keep the battery under charging. If we get the full sunlight from the solar panel or full power available from the transformer, then it will take 3 hours. But if you get both at a time, so full power from the both sources, then the battery will get full charge in a duration of 1 hour only. So that is the power parallelly we are providing to this battery pack. Coming to the charging circuits, so each charging circuits consist of three stages. One is a rectification. Both have the 4 diodes which will acting as a full wave rectifier to convert the AC to DC when we are providing the AC inputs. But in terms of solar panel, these 4 diodes will act as a polarity corrector. Means whenever we connect the solar panel in reverse polarity based reverse correction, then that will be corrected with the help of these 4 diodes, which is acting as a polarity corrector. Then output of this rectifier is input to the capacitor just to provide the filtration purpose if is any ripples occurred, and again 2 diodes. So the third stage is unidirectional current flow. So whenever battery is power fully charged, then in order to protect the source either from the transformer or solar panel, so we need to block the current flow from the battery to the sources. So for that purpose, we are making use of these 2 diodes which are acting as a unidirectional current flow. So once the battery is fully charged, so before demonstration, we should keep the battery under full charge. Then just on the power supply to this battery, there you can see the light indication in the transmitter section. So disconnect the transformer directly. Let us run the system on the battery pack. Just on the system, then you can see the light indication. So whenever EV vehicle coming on this coil, right, then automatically it will switch on and the respective voltage displayed on the LCD display. Right, we are moving away from this coil, then the power will be off due to unavailability of EMF. So here we have the 2 coils look like same. This is the transmitter coil. So whenever we are providing 12 volts DC input to this coil, then this circuit will convert the 12 volts DC to 12 volts of AC, and the frequency is 150 kilohertz. So whenever we are providing the AC signals to the copper coil, EMF will be generated around this coil. So when we place the secondary coil, the same copper coil, then it will get induced. EMF will be get induced in this one, and that is nothing but the voltage, same voltage. So when we are transferring from one coil to another coil, the power frequency won't change. Same 150 kilohertz of AC voltage will be given as input to this circuit, so which will convert AC to DC and then provide us the DC 5 volts. So that is the rating in our project. In real time, we can go up to 12, 48, 60 volts. Based on the ratings, we can design these 2 coils, and receiving also we can convert that voltage to the required voltage, and the receiving voltage will be measured by this PIC microcontroller and continuously displayed on this 16:2 LCD screen. So let us see the display again. Just on that, when it is on, we can move the vehicle on this one. This continuously light blinking is indication of the power is availability from the receiving coil. Right. So in this manner we came to know the how much of voltage is getting from the coils through the wireless power transmission. Thank you.